Hi everybody, welcome back to the Triple Math Practice Lab, Learning Through Practicing. So this is our practice set number 3, and we are going to talk about the functions, the graph, and the shape. So in this practice set, we're going to talk about the concave up and the concave down. So we're going to first, just like when we did increasing, decreasing, first we're going to look for the graph. So from the graph point, so how to identify is a concave up or concave down. And then the next practice set, we're going to give the equations, and then we're going to physically, go through the mechanical part of it, okay? So here, like we talk about, we're going to have 4 graphs. And from these 4 graphs, we're going to see which one, how do we identify the open interval for the concave up or concave down. So the first set of the 3 graphs, what they give us is the first derivative graph, okay? And then based on the first derivative, how do we decide the concavity? Then the second ones here is they give us, we have the one graph here is the graph given us is the second derivative graph. And based on the second derivative graph, how do we decide the concavity? So here, okay, so now if you want to pause your video, and now it's a good time, good place to pause it, and then try to do these 4 problems by yourself first. And when you finish, then resume the video, and then we can go over all these 4 problems together, and you can check your answers. Okay, so if you want, you can pause it, and I'm going to the whiteboard, and I will talk to you in the whiteboard here. Okay, welcome back. I hope you get a chance to do some of the practice before we go over here. Okay, so like we talk about for this practice set, we're going to just looking for the graphs and then to decide is a concavity, is a concave up or concave down here. And so the first thing is here, if given the f of x, we know the concave up and the concave down really. So like in here for the f of x, if you have some function look like this, this is the opening up. This is what we say is a concave up, right? So this is, we said this is a concave up. And then if you have a graph of something like this, then when they open downward, then this is, we call this a concave, what? Concave down. Okay, so this is basically, if they give you the f of x functions, so that's pretty easy to identify the concavity. So the concave up, basically the concave up, that means if you find the tangent lines, right? So along the, here. So if you find the tangent lines here, I'm sorry, this one did not do. Okay, so if you find the tangent line, that means the whole graph, the tangent lines, all the tangent line will be, like the graphs will be on the top of the tangent lines here, right? That's what we define the concave up, concave down. So concave down is here, if you find the tangent line along the points of the curves, right? So here, if you find those tangent lines here, then you find out that your curve is basically all below your tangent line. That's what we define as concave downs here. And the place where the concavity change, we call the inflection points, right? So if you have something go like this, okay, so if you have a function like this, then here, this is the point, where's the concavity change. That's what is the term, we call it an inflection point, right? I think everybody should be quite familiar with it. Okay, so this is what we call this inflection point. Okay, now this is by looking the f of x. That is pretty straightforward. How about, let's take a look at what is the f prime axis relations here, right? Okay, so if I only know the f prime axis here, then how do I decide is concave up or concave down here. Okay, so now I want to, show you graphs here, right? So here, okay, so this one's here, let's see here, then we can derive the, maybe I put a little bit exaggerate a little bit, all right? So if this is my f of functions here, right? So this is the black one, this is my f of x functions here, the black color here, this is f of x. And if I take the derivative of the f of x here, so in here you can see, so for example, this point, my tangent, my derivative is this, right? And this one's here, my derivative is this. This one's here, my derivative is. Then derivative becomes 0. Then here. Okay, so the orange one, this is my f prime x here. So like you see here, right? So the derivative start on my left-hand side here is negative, right? So they go to negative, and then they go to like get less and less and less. I shouldn't say less and less. So like they're getting closer and closer. And then the negative, and then you turn 0, and then become to positive slope, right? Then they get bigger and bigger and bigger, right? And so that's why. Then you see, hey, this is a concave up, right? So, but if you just look at the orange line, the slope, what happens here, you find out your f prime x is what? Really is increasing, right? So your f of f prime x is increasing. Then, because of the increasing, that's why the things change, right? The tangent lines start to change. So that's why I know is, by looking the graph of f of x, I know it's a concave up. So if you only use the f prime x, then I would know if this is a concave up, then the f prime x has to be what? Increasing. I use this notation, I say it's increasing, right? Okay, so now the same way is here. Let's take a look from the graph here. Let's see here, this graph here, right? So I know this is what? This is a concave down here, right? So now let's take a look at the derivative of this graph. The derivative first, when I start here, very steep, right? So when I start here, and then when I start here, then it becomes 0, then I start going down. Okay, so as you can see, when I first start here, right, my slope is what? My slope is very steep, right? So it's positive, very steep. And then gradually the slope getting less and less positive, then finally reach the 0. And then the slope of those tangent lines start to become negatives, right? Then become more and more and more negatives, right? So that's why I know this, so the f prime x, right? So in this graph here is my green ones, right? So it's a slope. So I know the slope is what? Is decreasing here, right? So the slope is decreasing. So that's why I know my f of x is what? Is a concave what? Concave down here. And here I better here instead of this one's here, so you not to get confused. So this is the f of x is a concave up when the f prime x is increased, right? So that is my first set. Let me write down here, right? So I know the f prime x increase. Then the f of x is a concave what? Concave up, right? Okay, so the f prime x is a decrease. Then my f of x is a concave what? Concave down here, right? So let's be careful. So let's see, is our first set of the formulas here. If the graph given us is the first derivatives here, right? So that's how is the first derivative related to the concave up and the concave downs here. Okay, so now let's take a look at the second derivatives here, right? So the second derivatives, right? So the second derivatives here, let me use this. Okay, so let me use the different colors here. Maybe second derivative use red, all right? Okay, so understand that second derivative of the x, second derivative is what? Second derivative is the derivative of what? Of the first derivative, right? So the first derivative, so the derivative of the first derivative, right? So in here, so when the f prime x, so the first derivative is increasing, so when the f of x is increasing, from the previous video, we know if the first derivative is increasing, then the f of x, if the f of x is increasing, then the first derivative is a positive, right? So now, because the f double prime x is a derivative of f prime x, so when the f of x, f prime x is increasing, so what happened to my f double prime x? That means the f double prime x has to be what? Greater than 0, right? Okay, so let's see here. Let's try to refresh what we had before. From the first video, we said when the f of x is increasing, then I know the f prime x is greater than 0, right? Then I know here, so when the f for x is decreasing, then I know the f prime x is less than 0. Now, you think about it here, right? So you just kind of go one extra order. So now if you put it here, if you replace this set of when the f prime x is increasing, then because this is f prime, so what happened here, this is f double prime x has to be equal to 0, right? So like here, if you go here, so this is f prime x is decreasing. Then what happened here is f double prime x here has to be less than 0, right? So that's why we got our second set of the formula, right? Because f double prime x greater than 0 implies that f prime x is increasing. Then f prime x is increasing. That means fx is concave up. Did you see here? Okay, so that's why we said f double prime x here is greater than 0. Then I know my f of x is what? It's a concave what? Concave up, right? So if my f double prime x is less than 0, then my f of x is what? Concave down. You see here? Okay, so basically that's why this is the place a lot of students get confused, right? So that's why we have like this is first derivative test, this is second derivative test, right? So remember that, right? So this is a refreshing, increasing or decreasing. We start always with the original function. So we said f of x increase, then I know the first derivative is greater than 0. So if you replace the f of x with f prime x, so you say f prime x increase, that means the next derivative, f double prime x, has to be greater than 0. That's how do we derive here. So when the f double prime x greater than 0, because it's f prime x increasing, f prime x increasing, fx concave up. You get that? Okay, so this is very important, right? So, the relation for the f of x, right? So that's why the relation was the f of x, f prime x, and the f double prime x. All right. Okay, so now if we do that, we understand this, then I think that it's pretty easy to do our graph here. Okay, so in here, let's take a look at problem A here, right? Okay, so these functions here is what? These functions is f prime x, right? So we want to see where the f of x is concave up or concave down, right? So remember, if they give us fx, so let's kind of refresh our memory. So we need to what? So f prime x is what? F prime x increase. Then I can say what? I can say f of x is a what? Concave what? Concave up, right? So the same way is here, that if you say it's a concave down, that means if the f prime x is decreasing. Okay, so now for these ones here, let's take a look at how do we write down the answers here. So we say f of x, concave up, it has to be increasing, right? So let me color that, increasing here. So from here to here, this is increasing. And where's the other? This part is increasing 2 to 3. Then what is here? From here, boom, 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 to here, right? All these 3 are increasing. So that's why I know the f of x, even they did not give us, so I know the f of x has to be concave up. So it will be 0 to 1, 2 to 3, and what? 5 to 7, correct? Okay, now I want to find where is the concave down. So remember, concave down, f prime x has to be decreasing since this is a graph of f prime. So I know this segment is decreasing, this segment is decreasing, and this segment is decreasing. All right, so I can say the f of x concave down. Okay, so concave down is 1, 2, 3, and 5, and 7, and 9. All right. Okay, so now the same way, let's practice one more time. This still is f prime x, right? So apply the same things here. Let's see when the f of x is concave up and when the f of x is concave down. Okay, so concave up, that means f prime x has to be increasing, right? So increasing here. I using this color, and what is the other one? Is this one is increasing, right? So the concave up will be 0 to 2, and 4 to what? 4 to 6, right? And the concave downs here, right? And the concave down is will be here, here, and here, concave downs here, right? So the concave downs, where is the concave downs here? The concave down will be 2 to 4, and what? 2 to 4, and 6 to 8, right? Okay, so let's take a look at the inflection point. Okay, so the refraction point is in here, right? Okay, so here, this one's here. So x equal to what? X equal to 2. You change it from concave up to concave down. Then in here, x equal to 4. You change it from concave down to concave up. So here again, x equal to what? 6, right? So I have 3 inflection points. And let's back to here, we forgot to do that. So this is the inflection points here, right? So let's take a look how many we have here. First, concave up to concave down. So x equal to 1. And here, change the inflection, x equal to 2. Concave down to concave up. And here, x equal to 3 is a change also. Then this one's here, x equal to what? 5, concave down to concave up. And this numbers here, concave, so this is 7, right? So it's a concave down, concave up to concave down here. Okay, now let's take a look the next ones here, right? So it's pretty easy. After you remember the principle, it's pretty easy, all right? Okay, so for these ones here, let's take a look. What is my f of x? It's a concave up, and the f of x is a concave down, right? So you look at the graph still is the f prime x, right? So it's the first derivative. As soon as you say the first derivative, increasing is a concave up, right? Okay, increasing, where is it increasing? Oh, from here. boom, 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 boom here. This is increasing. What is the other from here? Right? So those are increasing. So I can say, where is the concave up? So it's 3 and 6. And the 6 to what? 6 to infinity. All right. Then concave down. Okay, so let's take a look. Concave down is decreasing. So this segment is decreasing, right? So what is this segment's decreasing? So it's from 0 to what? 0 to 3. Okay, so let's take a look at inflection point. Okay, so inflection point is the concavity change. So concave down change to concave up. So this is my inflection point, right? So x equal to what? Equal to 3. Okay, now let's take a look at the last ones here. The last one, you say, oh, this one is very similar like the one we did before. Yes, be careful here. Now they say this is f double prime x, right? So it's be careful to look at the graph to see what type of function. So this is a double prime f. So we know if it's the second derivative is based on what? It's based on the positive or negatives, right? So if you remember the formula I wrote here, so we said f double prime x greater than 0, then the f of x is what? Concave up, right? So if f prime x double prime x is less than 0, then f of x is what? Concave down here. Okay, so now let's take a look. Where is my concave up and where is my concave down? So I said here, this is the, okay, so now here, this is the f of x, concave up, and this is the f of x, concave down, right? Okay, so remember, this is the second derivative. So the second derivative is greater than 0 is concave up, right? So let's take a look. Where is greater than 0? See here. So that means this segment, all here, right? All here is greater than 0, right? Because f double prime x is above the x-axis. So what is my concave up here? Concave up is from what? 1 to where? 1 to 7 here, right? Then the concave down is f double prime is negative. So that means in here. Correct? Okay, so concave down, I can say this is from 0 to 1 and what? And from 7 to 8, right? Now let's take a look at inflection. So the inflection point is a concavity changes, right? So I change from concave down to concave up. So here. So this is my first inflection point is x equal to 1. Then here, from concave up to concave down, this is my second. So it's 1 and the 7th here. All right. So I have 2 inflection points for here. So that's it. I really like those graphing problem because I think it clarify your concept about the concavity, increasing, decreasing, and the functions. If you understand the relation of the f prime and f double primes, I think that's a very, very important concept. And so don't forget, if you go back to here, those are the 2 things very, very important, right? So make sure you don't get confused and you understand why, okay? So if you can find some more practice problems, it's always good. So remember, practicing, it will make you getting better in the math here. Okay, so if you like the video, feel free to subscribe it. If you're still confused or you have any questions, leave me a comment and I will try to answer your questions here. Okay, so it's so nice to talk to you and you have a good day. And so looking forward to talk to you again in our next video. The next video, we're going to do the mechanical part. So when you give me a function, f of x function, then physically, how do I take the derivative and how to find the, the inflection points and decide the concavities, those things. Okay, so it's nice to talk to you and have a good day, and looking forward to talk to you again, in our next videos here. Okay, bye.